Okay. Yay. So we're gonna start combination. So yesterday in permutation, order was important for a combination. So a combination is a selection of R objects from a group of N objects where the order is not important. When the order is not important. The formula looks like this. You're picking R out of N equal to N factorial over N minus R factorial, R factorial. Again, we're not gonna use the formula, we're just gonna put it in a graphic calculator. So just like yesterday, I said that we use permutation when you see metals, races, something where the order is important. Today, the story problems will involve something like toppings of ice cream, let's say combos for food. The order is not important when you go to McDonald's if you have a combo of burger, fries, and pop, the way that they're gonna give it to you. So we're gonna do everything in the calculator. So you're selecting 3 objects out of 8, and how many different ways you can select. So you put an 8 in a regular window, put an 8 in a regular window, then you go math to the right probability, and then again you put a 8 in a regular window, then you go math probability down to C, and then 3. So 56 different ways you can select. So that would be 56. Next one, number 2, 10 in a regular window, math probability 0. So that will be 1. If you select none out of 10, it will be 1 way. Here's your 0 objects. And then if we select 12, C12, what do you think the answer will be based on what we learned yesterday? 1. Very good. So remember yesterday in permutations, I had the 3 different colors, and how many ways can I arrange them in permutation? We switch the colors around. When order is important, we got 6. But for combination, when order is not important, how many different ways I can arrange them? Here's your 3 colors in 1 way. Order is not important, we can just have 1. Same thing with 12 out of 12. The order is not important, you just pick 12 out of 12, so that will be 1. Okay, permutation or combination. You win 5 tickets to a rock concert from your local radio station, and you need to pick 4 of your 7 closest friends to come with you to the concert. In how many different ways can you pick 4 friends to take with you to the concert? Is that a permutation or a combination? Combination. How many ways you can pick 4 out of 7? Order is not important. It's not like they have to do a race to get to the concert. So you're picking 4 out of 7, so 4, C7. You're picking 4 out of 7 closest friends. So let's see in how many different ways can you pick them. So 7, that means what? The order is important. So seated, arranged, order is important. So then you and your friends, since you're 4 friends and you're 5 out of how many? How many people went to concert? 5. In how many different ways can you and your 5 friends be seated at the concert? So 5 people at the concerts out of 5. Sorry, P. So 5, math, probability number 2. So that would be 120 different ways you can get seated. All right, so now we're gonna move to the multiple events. When finding the numbers of ways both an event A and an event B can occur, you need to multiply. So every time you see the word and, you're gonna multiply. And every time you see the word or between the two events, you add. So Maggie's teacher gives her a choice of 10 books to read. So there are 10 total. 5 are fiction. So let's see, 5 are fiction and 5 are nonfiction. 10 total, 5 fiction, 5 nonfiction. If the order in which she reads the book is not important, so we're using combinations, how many different sets of 4 books can she read? 4 books. So we're picking out of 4. They didn't mention if it's fiction or nonfiction. So 4 books out of 10 books. So we're picking 4 out of 10. How many different sets of 4 books can she read? So let's see. We have 10, math, C4. So 210 different sets. All right, and how many groups of 4 books are all books either fiction or nonfiction? So first of all, I have the word or, so I need to add. So we're picking fiction out of how many, so in how many groups of 4? We're picking 4 out of the fiction. How many fictions we have? 5. So we're picking groups of 4 out of the fiction, which are 5, or we're picking 4 out of the nonfiction, which are again 5. How many groups of 4 books are all the books either fiction, 4 out of 5, or plus 4 out of 5? So let's put that in a calculator. 5, math. So that would be 5. This is the same thing, 5 plus 5. So the answer is 10 different groups. All right, the Canton Student Congress consists of 6 seniors, 5 juniors, 4 sophomores, and 3 freshmen. How many different committees of exactly 2 juniors and 2 seniors can be chosen? Is committee important or not? No. If it says they run for positions like president, or the committee is just everybody's equal. So this is combination. Committee is combination. I'm picking 2 juniors and 2 seniors, and that means I'm going to have a multiplication. So I'm picking 2 juniors out of how many juniors? 5. Then we're gonna pick 2 seniors. How many seniors? 6. So if you plug that in a calculator, you get the first one, you get 10 times 15. Now that you know how to put permutation and combination in a calculator. So that would be 150 different committees. For example, you can pick senior number 1, senior number 5, and junior number 3, and junior number 4, and a more combination of that. Okay. Using a standard deck of cards, I put the cards here. So there's 52 cards in the deck of cards. How many different 5 card hand are possible? So that we're picking 5 out of 52. So 5 out of 52. So 52 mat 5. So that will be 2,598,960. Hold on, let me figure out how to, I think this is pause. On to William Shakespeare wrote 38 plays, so the total is 38 plays. They can be divided into 3. Out of the 38, 18 are comedies, 10 histories, 10 tragedies. How many different sets of exactly 2 comedies and 1 tragedy can you read? First of all, I want you guys to pay attention to these keywords. Exactly, at most, and I'm going to change this problem to have it at least. So they're going to be 3 different scenarios. How many different sets of exactly 2 comedies and 1 tragedy can you read? So and is going to change into multiplication. We're picking 2 comedies to read out of how many comedies? 18. Times, we're picking 1 tragedy out of how many tragedies? 10. Order is not important. They even say find combinations. And then if you put that in a calculator, you get 153 times 10, which is 1,530 different sets. So if you see the word and, you have multiplication. If you see the word or, you have addition. All right. How many sets at the most 3 plays can you read? What's at most? Less than or equal to or greater than and equal to? Less than and equal to. So that means less than and equal to 3. I'm picking 3 plays out of 38 plays. So I either chose to read 3 out of 38, less than and equal to 3, or I can choose to read 2 out of 38, the summer, or I can choose to read 1 out of 38, or I can choose to read none, 0 out of 38. Again, how many sets of at most plays can you read? At most is less than and equal to 3. You either read 3 or 2 or 1 or none. You set them up, and then after you put them in a calculator, you get 8,436 plus 7 or 3 plus 38 plus 1, which equal to 9,178 sets. And then for C, I'm going to change it to how many sets of at least 36 plays can you read? So change C into how many sets of at least 36 plays can you read? So what's at least? Greater than and equal to 36. Okay, so at least 36 plays out of 38. So I can choose to read 36 out of 38, or I can choose to read 37 out of 38, or I can choose to read 38 out of 38. So exactly, at most, at least. And then if you have those, you're gonna get 7 or 3 if you put those in a calculator, plus 38 plus 1, which is equal to 748 different sets. So the total is 742, not 748, sorry. Again, we did the Pascal triangle in Unit 2, so we're not doing that anymore. So we're only looking at cars. First of all, the way this printed, it's wrong. We're supposed to have another row of what's missing? Hearts, spades. What's the diamonds are missing?
No, clubs.
Clubs. So there's more here. Clubs are here. Diamonds, spades. So there's another row. Look up on the board. You have all the cards here. Spades are missing. So there's another row of spades, and then these go down to 2's missing, and also the ace is missing. Aces are missing for all 4 colors. So first of all, the cards are on the board during the quiz or test. If you don't know how many cards are or how many spades, there's 13 of each. 13 clubs, 13 spades, 13 hearts, and so on. They're half and half. They're 26 red, 26 black cards. Notice there's 4 of each. 4 2s, 4 3s, 4 4s, and so on. How many face cards are there? The one they have a face on it. 12. There's 4 kings, 4 queens, 4 jacks, so 12 face cards. But the poster up on the board gonna be here during the test. So how many different 5 cards, so we're picking 5 cards, can be formed that consist of 1 jack and 4 other cards? So I have n, so I have multiplication. So I'm picking 1 jack out of how many cards? So we have to pick 5. I'm picking 1 jack out of how many jacks? 4. There are 4 jacks. 1, 2, 3. There's one more here, 4. So we're picking 5 cards. 1 is a jack out of 4 jacks possible. And the other cards, if I pick 1 here, 4 out of how many other cards? If there's 52 altogether cards in a standard deck of cards, 52 minus 4 is what? 48. So 1 plus 4 adds up to how many you're picking? 5. And then 4 and 48, they add up to the total of cards in a standard deck of card. Everybody good? So that would be 4 times 194,580 after you put them in a calculator, and that's 778,320. Questions? All right. How many different 5-card hand can be formed that consists of, I want you guys actually to change this, at most 2 hearts. So just like the problem that we previously did, at most means less than and equal to 2 hearts. Okay. So I'm going to have something like this. That was exactly 1 jack and 4 other cards. This is at most 2 hearts. So I can pick 2 hearts, or I can pick 1 heart, or out of the 5, or I can pick 0 hearts. Is less than and equal to 2. 2 or a 1 or a 0. How many hearts are all total? How many? No. 13. 13 hearts, 13 spades, 13 diamonds. These are all 13 if you count them down, including the aces. So 2 hearts out of 13. I'm going to have plus here and then plus there. I need to come up here with something that was the same here. So 2 out of 13 are hearts. I'm picking 5 cards. The other one times the other 3 are not hearts. So what's 52 minus 13? 39. So again, less at most 2 hearts, less than and equal to 2. So you either pick 2 or 1 or 0. So now I'm doing 2 alone. 2 out of 13 are hearts. I'm picking 5 cards, and the other 3 are not. Now I'm picking the probability of getting 1. 1 out of 13 are hearts. And then the other 4 are not. 1 plus 4 is 5. I'm picking 5. And 13 plus 39 is 52. Or 0. That will be 0 out of 13 are hearts. And the other 5 are hearts. So 0 plus 5 is 5 cars that I'm picking, and 13 plus 39 is 52. So that's the possibility at most do 2 plus 2 or 1 or 0. And then if you add all those together, so you do them separately, the final answer will be 2,357,862. So since that, in the homework, since we're not doing Pascal triangle, in the homework, you're gonna cross out on this page 19 through 23. 19 to 23. And in the back, we already did this. In the back, you crossing out, hold on. Let me pick up your page. So here, 19 to 31 here, you take out, and in the back, everything with the Pascal triangles, you cross out. 32 to 37.
We don't have to do that on the actual test.
No, no. Pascal triangle is not an actual test.